Well, I'm going to show you that that's not the case. I'm going to go through and explain what exactly you can do with only 0 permissions. So the first thing you can do is you can actually reboot a phone. There's a reboot permission, and this permission is set as protection level signature or system. And what that means is that you have to either be on the system partition or you have to be signed by the same signature as by the manufacturer of the phone's signature, and therefore most apps can't access this. There's no way to be installed from the market onto the system partition, for example, unless you were already there. But that's not going to stop us. So there's a couple different approaches here. One of them that we found that's sort of the easiest and most reliable involves toast notifications. So a toast notification is a notification of something that occurs in the background that will appear on top of any activity that you're running. You can think of this as like a growl notification. So here's an example. Someone's in the keypad application and a toast notification pops up and tells them something about something that happened in the background. So here's just a simple, this is kind of the hello world of creating a toast. You can just easily call this helper method and display a toast on the screen, and then all I've done is throw it inside an infinite loop. And every time that you create a toast, it actually creates a weak JNI reference in the system server. And as you can see, at 2001 global references, the system says, "I can't let you do that, Dave," and crashes with a SIGSAG V. So the actual version kind of or the actual number of references sort of depends on the phone, but we found 2001 is almost every phone at 2001 global references. System server crashes and the phone reboots. All in all, that process takes about 20 seconds from when you display the first toast. So any app with no permissions can cause a phone to reboot within about 20 seconds of launching. But that would actually display the text "Hello World" on the screen for 20 seconds before your phone rebooted, and you might notice that something was up. So we can actually do something that's called a custom toast. So we don't have to just display text. We can actually display any view that we want. So here's an example of Powdered Toast Man, an image of Powdered Toast Man being displayed on top of the phone screen as our custom toast. But we can also create a custom toast that is completely invisible. So here, this code snippet just shows creating a new view with nothing in it and then showing that. So this is completely invisible. The user has no idea that anything's going on except maybe that their phone is heating up a bit, and then in 20 seconds their phone will just reboot. So now that a phone is rebooting, we might want to request the receive boot complete permission. So this permission allows apps to automatically start on boot. And this one's just a little too easy. You can just comment out the request for the permission. It still works. It works on all Android OS versions. This permission is not enforced, period. And in fact, if you do the previous attack, the 20 seconds that it takes to reboot the phone again actually starts much earlier than when the user can interact with it. So, if you combine these, you'd maybe have a few seconds before your phone just reboots again. So another thing that a lot of app developers would like to be able to do, and malicious developers as well, is to be able to start an app on installation. So you can imagine that you could combine this with say, a phishing attack. You download an application and you're in the Android market and a pop-up appears as soon as you're done downloading it. You don't suspect that it has anything to do with the application that you just downloaded it, because apps can't run until you start them. That's like a principle of Android. So if you could pop up a screen that said, "Please enter your Google username and password," you might actually believe it. So there's no permission that allows this functionality, but there is still a way to do it without any permissions. The Google Analytics has a referrer tracking, and this code snippet is actually just stolen from Google Analytics SDK for Android apps. And basically what it does is it allows you to track the source of where someone downloaded your app. So maybe they clicked on an AdMob link and you want to be able to see which AdMob link they clicked on, or maybe they clicked from a website and you want to be able to see what website linked into the market to your application. But we don't have to use the Google Analytics receiver here. We can just write our own receiver and have this exact same intent filter, and we'll be able to start as soon as an application is installed. But there are some caveats here, namely that you have to have a referrer associated with the download. So if you were just browsing through the market and you clicked on an app to install it, this wouldn't necessarily work. It would work if you clicked on an AdMob link or a web link with any sort of referrer information attached to it. However, in Android 2.2, they actually added a new feature that always includes a referrer that tells you, in this case, it tells me that I downloaded this app from the games category in the free section, and it was the 34th item on the list. So as of Android 2.2, you can expect this to work on every single download of your application. So the next thing that I want to talk about is what we call the circle of death. And this is basically a hostile takeover of the UI without requesting any permission. So this is something that, once again, any app on your phone can do this. Any app that you download, Solitaire, Tic-Tac-Toe, etc. What you do is you just launch an activity that consumes all key presses. So here we've just overridden the on key down event and just returned true, which says, oh, we handled that key press, don't pass it on to anyone else. And there's a caveat there, though, that you can't actually swallow the home button. So the home button would still allow someone to get back to the home screen. So what you need to do there is just relaunch your activity when it exits. Of course, Android doesn't make it that easy. You can't just, as your app is exiting, launch the intent to start your app again. They do detect that kind of behavior and stop it. So that's where the circle of death comes into play. So when the activity is destroyed, all you have to do is launch a service. And so here we launched a restart service in our malicious activity when it's destroyed. And all that service does is relaunch the original activity. So it's just a cycle, and then as soon as that app dies again, the service would start again, launch the activity again, and you wouldn't be able to escape from this without, say, restarting your phone, or you can actually reboot into safe mode, which makes it so no non-system apps are running on your phone, and then you could find the malicious app and uninstall it. And if you want some bonus points, you can do something fun like play a nice sound. So here I have an example of an application that would just completely take over the UI, and you could pay $5 on PayPal to unlock it. You could donate to someone. If I hit any buttons here, nothing works. And so I'm just going to pop out the battery. Once again, that's something any app can do, no permissions requested. So the last thing I want to talk about is exfiltration. Can an app that is not requesting the internet permission access the internet? If an app doesn't request internet, someone might be more willing to trust it with other permissions. Maybe I'm not worried about an app that can read my contact data as long as I know it can't send it off to a server. And I would be willing to install that app on my phone if I don't see this permission. But if I see both of those, I can assume they might be stealing my contacts. So your app's sandbox can access the internet, but that doesn't mean that it can't communicate with other apps. So an app can simply ask its neighbor, which their activity will run in their own sandbox. So the simplest way to do this would be to just pop open a browser. So we can just pop open a browser and point it at a URL that contains some information about, say, the user's latitude and longitude, and sends that off to a server. However, that does actually pop open a browser. You can't pop an activity to the bottom of the stack or anything like that. It forces, anytime you start a new activity, it's on the top of the stack. So the user would see this, and that would kind of give away what you were doing, but at least you would have gotten a message sent out to your server. However, I'm willing to bet that we can actually do this secretly. So, of course, the easiest thing to try would be to just obscure the browser. Create another activity right on top of it, right after you create it, and hope that the user doesn't see anything. Unfortunately, this actually does stop the page from loading. So let's try something else. Let's try only popping open the browser if the screen is off. So we can actually detect our APIs to tell if the screen is on or off, and we could only do this while the phone was in the user's pocket, for example. So all we need to do is make sure that when the screen turns back on, we close the browser, and it would also be useful to redirect to a safe-looking URL, so if the user pops open their browser later, they're not like on some weird suspicious page. Or if you want to do even better than that, you could try to read the page that the user was on recently from the logs, which Tim will be discussing in detail later. So here's the basic code for what you would do. You just ask the power manager, is the screen on? If the screen is on, or if the screen is not on, then you would pop open a browser, and if the screen was off, you would, and a browser was displayed, in that case, you would just launch the home intent, which is the equivalent of pushing the home button, hides the browser, and you don't see it anymore. All that, zero permissions. If you wanted to kill the browser, it would require permission to kill another task, and that might look suspicious. But this is a way you can do all of this with zero permissions. So that gives us one-way communication. But what about two-way communication? Can we also receive a message back from the server? And yes, of course we can. So an easy way to do this would be to just pop the browser open to, say, a zip file, anything with a downloadable content type, and the browser will automatically save it to the SD card in the downloads directory, and anyone can read that. You don't need any permissions to read any file off of the SD card. However, there are some downsides to this. So it actually builds up a notification every time you download a file this way. And so you can see it would just create hundreds and hundreds of notifications for the user, and they would probably suspect that something was up. But you would have succeeded in your goal of two-way communication. If you want to clean up the file system afterwards, you'd need the right external storage permission. However, I will point out that this permission is actually automatically requested for every app that wants to support Android 1.5. Therefore, people are very used to seeing this permission. So how about we try something else? How about a custom URI? So we can register, or Google Maps registers for the protocol geo, like colon, latitude, longitude. And when you click on a link of that format, it automatically pops up the Google Maps application and shows you that location. So we can actually do the same thing with our application. We can register ourselves for the NetHack protocol, and then the page on the server side can automatically redirect to a page like NetHack colon data with some private information that would be the response from the server. So here you can see this is a statically declared activity with an intent filter inside our Android manifest. We're requesting the NetHack scheme, and the host is data, which is just what should be the first section of the what's the host of the URL. So you can think another example here would be the YouTube app would set the scheme to be HTTP, and the host would be youtube.com, and that's why when you click on a link to a YouTube video, it opens in the YouTube app instead of in the web browser. And note that this is actually an activity, although we're using it like a receiver. So this would be something that we would want to happen completely in the background with no user interaction at all. But the idea behind a data intent filter is for something that does involve user interaction. This is supposed to be, I click on a link in the browser, I click on a telephone number in the browser, I click on a map location, something like that. It's supposed to pop up an activity. So here's the activity that it would pop up in this case after that page on the server redirects. it would go to it would launch this activity with an intent that contains the data